The sclera, also known as the white of the eye, is the opaque, fibrous, protective, outer layer of the eye containing mainly collagen and some elastic fiber. In humans, the whole sclera is white, contrasting with the colored iris, but in other mammals the visible part of the sclera matches the color of the iris, so the white part does not normally show. In the development of the embryo, the sclera is derived from the neural crest. In children, it is thinner and shows some of the underlying pigment, appearing slightly blue. In the elderly, fatty deposits on the sclera can make it appear slightly yellow. The lens is a transparent, Biconvex structure in the eye that, along with the cornea, helps to refract light to be focused on the retina. The lens, by changing shape, functions to change the focal distance of the eye so that it can focus on objects at various distances, thus allowing a sharp real image of the object of interest to be formed on the retina. This adjustment of the lens is known as accommodation, see also below. Accommodation is similar to the focusing of a photographic camera via movement of its lenses. The lens is more flat on its anterior side than on its posterior side. The lens is also known as the aquila, Latin, a little stream, dim, of aqua, water, or crystalline lens. In humans, the refractive power of the lens in its natural environment is approximately 18 diopters, roughly 1/3 of the eye's total power. The ciliary muscle is a ring of smooth muscle in the eye's middle layer that controls accommodation for viewing objects at varying distances and regulates the flow of aqueous humor into Schlemm's canal. It changes the shape of the lens within the eye, not the size of the pupil, which is carried out by the sphincter pupillae muscle and dilator pupillae. The ciliary processes are formed by the inward folding of the various layers of the choroid, i.e., the choroid proper and the lamina basilis, and are received between corresponding foldings of the suspensory ligament of the lens. They are arranged in a circle, and form a sort of frill behind the iris, around the margin of the lens. They vary from 60 to 80 in number, lie side by side, and may be divided into large and small. The former are about 2.5 millimeters in length, and the latter, consisting of about 1/3 of the entire number, are situated in spaces between them, but without regular arrangement. They are attached by their periphery to 3 or 4 of the ridges of the orbiculus ciliaris, and are continuous with the layers of the choroid. Their opposite extremities are free and rounded, and are directed toward the posterior chamber of the eyeball and circumference of the lens. In front, they are continuous with the periphery of the iris. Their posterior surfaces are connected with the suspensory ligament of the lens. The vitreous body is the clear gel that fills the space between the lens and the retina of the eyeball of humans and other vertebrates. It is often referred to as the vitreous humor or simply, the vitreous. The vitreous humor is a transparent, colorless, gelatinous mass that fills the space in the eye between the lens and the retina. It makes up 4/5 of the volume of the eyeball. The vitreous humor is fluid-like near the center, and gel-like near the edges. The vitreous humor is in contact with the retina. It does not adhere to the retina, except at the optic nerve disc and the ora serrata, where the retina ends anteriorly, at the Wieger band, the dorsal side of the lens. It is not connected at the macula, the area of the retina which provides finer detail and central vision. Aquaporin 4 in Muller cell in rats, transports water to the vitreous body. The superior oblique muscle, or obliquus oculi superior, is a fusiform muscle originating in the upper, medial side of the orbit which abducts, depresses and internally rotates the eye. It is the only extraocular muscle innervated by the trochlear nerve. The superior rectus muscle is a muscle in the orbit. It is one of the extraocular muscles. It is innervated by the superior division of the oculomotor nerve. In the primary position, the superior rectus muscle's primary function is elevation, although it also contributes to intorsion and adduction. The medial rectus muscle is a muscle in the orbit. As with most of the muscles of the orbit, it is innervated by the inferior division of the oculomotor nerve. This muscle shares an origin with several other extrinsic eye muscles. The annulus tendineus, or common tendon. It is the largest of the extraocular muscles and its only action is adduction of the eyeball. Its function is to bring the pupil closer to the midline of the body. It is tested clinically by asking the patient to look medially. The optic nerve, also known as cranial nerve 2, is a paired nerve that transmits visual information from the retina to the brain. In humans, the optic nerve is derived from optic stalks during the 7th week of development and is composed of retinal ganglion cell axons and glial cells. It extends from the optic disc to the optic chiasma and continues as the optic tract to the lateral geniculate nucleus, protectal nuclei, and superior colliculus. The annulus of Zinn, also known as the annular tendon or common tendinous ring, is a ring of fibrous tissue surrounding the optic nerve at its entrance at the apex of the orbit. It is the common origin of the 4 rectus muscles, extraocular muscles. It can be used to divide the regions of the superior orbital fissure. The arteries surrounding the optic nerve are sometimes called the circle of Zinn-Haller, CZH, 2. This vascular structure is also sometimes called circle of Zinn. The cornea is the transparent front part of the eye that covers the iris, pupil, and anterior chamber. The cornea, with the anterior chamber and lens, refracts light, with the cornea accounting for approximately 2/3 of the eye's total optical power. In humans, the refractive power of the cornea is approximately 43 diopters. While the cornea contributes most of the eye's focusing power, its focus is fixed.